and welcome to Dr. G's Technique of the Week, Geometry Edition. Today we're going to be proving that two triangles are congruent and taking a look at the general process that goes into writing a proof in geometry about two congruent triangles. So in this particular example, we're given this diagram. We're told that line segment PN is parallel to line segment LM, and that O is the midpoint of LN. And then we want to prove that triangle MLO, so this triangle on the right, is congruent to triangle PNO, this triangle on the left. So the first thing that we want to do is look at the information that's given to us in the problem and any information that is given to us on the diagram, and just write that down. So on the diagram, we're given that PN is parallel to LM. So away from where I'm going to write my proof, I'm just going to make a note of that in case it ends up being something that we need to use in the actual proof. So PN is parallel to LM. Okay? We're also given that O is the midpoint of LN. These are our two sort of given facts. So we've written those down. Our next step is to look at the diagram, look at this information that we're given, and see what else we can derive from that. So in particular, what information can we get from the fact that O is the midpoint of line segment LN? Well, we can say that LO and NO must be congruent just by the definition of a midpoint. Midpoint means that it splits this line segment in two perfect halves. And at least for now, that looks to be all we can say about any side lengths between these two triangles. But there are some angles that we can show to be congruent using other theorems about angles. So take a moment to look at this diagram and see what other angles you can say are definitely congruent to each other. The first thing that I notice looking here is that we have a pair of vertical angles. Right? PON and MOL are vertical angles, and we know by the vertical angle theorem that vertical angles are always congruent. So I'm going to make a note that I know that PON is congruent to MOL, and that the reason I know that is that they're vertical. Now we can use the fact that we have these two parallel lines to find some other pairs of congruent angles, because we have some alternate interior angle pairs formed by these two parallel lines and our two transversals. So which angles are going to be pairs of alternate interior angles that are therefore congruent? So we have a couple pairs here. We can see angle P and angle M. I'm going to write down a note to myself that that's because they are alternate interior angles. And using the other transversal, we can also see that N is congruent to L. Right, now I have actually more information that I need in order to prove that these two are congruent. I only need two pairs of congruent angles and one pair of congruent sides. So which ones you pick just depends on which congruence criterion you want to use. If we keep P and M, which are not touching the side lengths that we know are congruent, then we'll be using an angle-angle side proof. And if we are using angle N and angle L, which are touching those pair of congruent sides, that'll be an angle side angle proof. So I'm going to pick N and L to do angle side angle, but either one is valid. So there's one pair of congruent angles, here's a second pair of congruent angles, and there's our pair of congruent side lengths. And that's enough to use angle side angle. And so now I'm ready to write my formal proof. The first step is to start out with the things that we were given in the problem that we used. So in this case, that Pn is parallel to Lm. So I put that in my statement columns if we're writing this sort of formalized two-column proof, and its reason is just that it was given in the problem. And we were also given that O is the midpoint of Ln given in the problem. Now, from that midpoint statement, I got my pair of congruent sides, that LO was congruent to NO, just by the definition of a midpoint. And the next thing I did was find two pairs of congruent angles using first the vertical angle theorem and the alternate interior angle theorem. So we found that angle PON is congruent to angle MOL by the vertical angle theorem. And we saw that angle N was congruent to angle L by the alternate interior angle theorem. So now we have our two pairs of congruent angles, our one pair of congruent side lengths, and we're ready to finish out our proof. We always want to end our proof by stating what we have proved. So the last line of our proof is going to be that triangle MLO is congruent to triangle PNO, and that's by the angle side angle congruent criterion. Now it's time for you to get some practice with these new ideas. See you next time on Dr. G's Technique of the Week.